Troubleshooting guide, communication faults, CAN bus and sensor issues. Modern EVs rely on networks of sensors and control units talking to each other. When that communication breaks down, the car can behave oddly or not work at all. Two main areas here are CAN bus faults, or other vehicle network issues, and sensor miscommunication or failure, which might not be a network fault per se, but a sensor feeding wrong data. We'll tackle how to diagnose communication problems that result in faults like vehicle communication error, unable to read battery data, or various system malfunction lights. CAN bus communication issues. EVs typically have multiple CAN bus networks, high speed for powertrain, maybe another for battery, etc. A fault on the CAN bus can lead to loss of messages between ECUs. Because EV systems are tightly integrated, a CAN fault can trigger warnings or even stop the vehicle to fail-safe mode. Symptoms: multiple warning lights coming on simultaneously, e.g., ABS, powertrain, steering all lighting up together, often a classic sign of CAN failure, because if one critical ECU, like the battery ECU, goes offline, other systems complain. The car might enter a fail-safe or limp mode, as was seen in the Hyundai recall. An electronic CAN bus fault put the Ioniq into a mode with limited acceleration. In some cases, no start. If the CAN network that carries the ready signal is down, the car won't go to drive mode. Or you might get intermittent chimes and flickering of system errors when hitting bumps, could indicate a loose CAN connection making contact intermittently. Possible causes: wiring issues. The twisted pair wires of CAN could be damaged, shorted together, shorted to ground, or one side open. Commonly, an accident repair or aftermarket accessory installation can inadvertently mess with CAN wiring. Faulty ECU. One of the control units on the bus can fail in a way that it drags the whole bus down. For instance, a bad transceiver in a module can hold the bus in a dominant state. This is tricky because it might appear like everything is offline, but the root cause is one module. Terminator resistor issue. CAN buses have 120 ohms resistors at each end. If one is missing or a third one got introduced by mistake, the bus impedance is wrong and communication can be unreliable. If someone replaced a module and the new one had a terminator that wasn't needed, that can cause problems. EMI or ground offsets. Less common, but electromagnetic interference or poor grounding between components can cause CAN errors. For example, high current cables running parallel to CAN without proper shielding could introduce noise. Water ingress, corrosion. Corroded connectors can introduce resistance or shorts on CAN lines. A bit of water in a junction can cause intermittent CAN failures, especially as temperature changes might dry or wet the connection intermittently. Troubleshooting steps. Read DTCs. There are usually U codes, network codes, logged. For example, U0100 lost communication with ECM, PCM, or U0121 lost COM with ABS module. If you see a bunch of U codes, list which modules cannot be contacted. It might say, no COM with battery pack, or no COM with inverter. The module that everything else is complaining about is likely the one that's gone silent, or the one that's blocking the bus. Note: if all modules report lost COM with one particular module, that particular module could be the culprit. Either it died, or the bus line to it is cut. Physical inspection of wiring. Identify the CAN bus in question from wiring diagrams. Visually inspect connectors and harnesses, especially in areas that might have been disturbed, around the battery pack connectors, under car wiring, etc. Look for pin push-outs in connectors, one pin not seated fully. Check for any obvious breaks or shorts, burn marks if a wire got pinched by metal. If the CAN wires go through an inline connector, disconnect it and see if any green corrosion is present. That's a trouble spot. Measure CAN resistance. With the car off, you can measure across CAN high and CAN low lines at the diagnostic port or an accessible point. Proper reading should be approximately 60 ohms, to 120 ohms in parallel. If you measure significantly different, like approximately 120 ohms means one terminator missing, approximately 40 ohms means an extra one or a partial short, infinite or very high means an open circuit on CAN, 0 ohms means shorted wires. That gives a clue. For instance, if you read 120 ohms, likely one end's terminator isn't connected. Maybe the wiring to one module is broken or that module isn't powering up. Module power, ground. Sometimes the issue isn't CAN wiring at all, but a module not powering on, so it can't communicate. If the battery ECU's fuse blew and it's off, all other ECUs can't talk to it and log U codes. Check that each major ECU on the bus has power and ground. In EVs, the BMS controller in the battery pack often has its own fuses. Ensure it's alive. If one module is dark, focus there. It could be a simple fuse or connector fix. Isolate sections of bus. If the CAN network can be split, some have multiple segments connected by a gateway. Isolate to find the problematic leg. For example, unplug half the modules, or a gateway connector that separates them, and see if communication resumes among the remaining. There's a technique. Disconnect modules one by one. If you unplug one particular module and suddenly the CAN bus comes back to life, others start communicating, that module or its connection is the cause. Possibly an internal short on CAN lines of that module. This method requires caution to not disconnect things with power on unless recommended, and watch out for needing to keep terminators in circuit. But it's effective, e.g., disconnect the motor controller, check COM. If still down, reconnect and disconnect BMS, check COM, and so on. Eventually, you find removing a certain module allows others to talk. That module likely needs repair or replacement. Use of CAN scanner tools. If you have a CAN analyzer, you can plug into the bus and observe frames. If it's completely silent, either no module is transmitting or the bus is held in error state. If you see error frames, that means something is trying to talk but erroring out, likely a short or bad transceiver. If you see one ID repeatedly or garbled data, could be a specific module stuck. These are advanced techniques, but worthwhile if standard ones fail. After fix, clear codes and test. Once you think you fixed it, say, repaired a wire or replaced a faulty unit, clear the DTCs and run the car. Ensure all modules are communicating, usually indicated by no warning lights and ability to query each ECU with scanner. Perform a full systems check, drive the car, check that features like regenerative braking, which relies on COM between brake ECU and motor, work, etc. Example. A workshop had an issue with an electric bus where it wouldn't go. Ready, turns out a mechanic had accidentally left a diagnostic terminator plugged in, adding an extra resistor on the CAN line. The CAN bus was at the wrong impedance, causing unreliable comms. Removing the extra terminator solved the problem. This kind of thing shows up in our 60 ohms resistance check step. Another example on a car. Water ingress in a connector to the battery pack caused CAN corrosion. The car intermittently lost communication with the battery, throwing a service battery system light and shutting down drive. The fix was cleaning and reseating that connector, and ultimately replacing it to prevent recurrence. Resolution. Communication restored means the car's network errors go away. The vehicle should no longer be in limp mode and all those U codes should remain gone after clearing. It's gratifying to see a car that was lit up like a Christmas tree with errors go back to normal simply because you fixed a wiring or module issue. Still, remain vigilant for a while. Sometimes an underlying cause, like water ingress, could cause issues again if not fully remedied. Ensure you seal connectors, reroute wires away from heat, etc., as needed to prevent repeat faults. Sensor miscommunication. Faulty sensors. Not every sensor communicates via CAN. Some are directly wired to their ECU. But from the perspective of the whole vehicle, a bad sensor means bad data shared across the system. Let's consider the example of sensor faults that can mimic larger issues. EVs have sensors for temperature, voltage, current, speed, position, etc. Symptoms could be very specific, like an error code for accelerator pedal sensor fault, leading to no acceleration, or more subtle, like incorrect range estimate, or fan running all the time because a temp sensor reads hot. Often a single sensor fault triggers a limp mode for safety. For instance, if the battery pack current sensor malfunctions, the BMS might not allow charging or discharging, effectively disabling the car. Or if a wheel speed sensor fails, you might see ABS and traction control lights, and also region braking might be disabled, since EVs often rely on wheel sensors for regenerative braking algorithms. Possible causes: sensor element failure due to age or manufacturing defect. Wiring, connector issue. Just like other wiring, sensor wires can break or short. Out of calibration or drift, especially current sensors or voltage sensors might drift, causing the BMS to misread state of charge. External damage, e.g., a wheel speed sensor cracked by debris. Software misinterpretation, occasionally, a sensor is fine but the ECU misreads it due to a software bug. Then an update can fix the false fault. Troubleshooting steps. Identify the suspect sensor from codes or data. Error codes help. For example, P0A0F, drive motor inverter temperature sensor circuit would tell you to check that sensor. If no direct code, use live data. If one temperature reading is implausible, e.g., one module reads 85 degrees Celsius while others 30 degrees Celsius, that stands out. Or if the state of charge jumps around, maybe the voltage sensor is flaky. Physical inspect and receipt connectors. This is basic but fixes a lot. Unplug the sensor connector. Power off car first if it's high voltage area, and plug it back in. Many times, slight oxidation can cause high resistance. Reseating can scrape contacts clean. Check for damaged wires leading to it. Test the sensor if possible. Depending on the sensor, there might be a way to bench test. For instance, a thermistor's resistance can be measured to see if it matches expected value at ambient temperature. A pressure sensor might be harder to test without specialized tools, but you can test supply voltage to it and ground continuity. For a current sensor, like a Hall effect on the battery cable, you might compare its output reading on scanner with a known current or with another sensor. If a sensor is cheap enough, like a speed sensor or thermistor, sometimes it's easier to just replace and test. Sensor alignment, calibration. Some sensors like steering angle, accelerator pedal, etc., might need calibration. Ensure if the part was replaced or if the battery was reconnected, that any required calibration was done. A miscalibrated sensor can throw a code or cause weird behavior even if it's not broken. Check for firmware issues. On rare occasions, we find that multiple sensors throwing implausible values are actually a sign of an ECU firmware bug. If a pattern emerges, like every time two sensors read a certain combination, the ECU misfires. See if an update is available. Simulate or substitute. If you truly suspect a sensor but aren't 100%, you can try simulating its signal. For example, if a temperature sensor is suspect, you could temporarily put a resistor in place that corresponds to a normal temperature and see if the error goes away. Or swap sensors. If there are two similar ones, like two coolant temp sensors, swap them and see if the fault moves. Example: an EV had its cooling fans running at full blast as soon as the car was on, even when the battery and motor were cold. Diagnostics showed the coolant temperature sensor reading a fixed 40 degrees Celsius, which is a typical open circuit reading, default for an open thermistor. Indeed, the sensor's connector had come loose. The car thought the coolant was extremely cold, or sensor bad, and as a failsafe, ran fans. Some systems do this if they can't read temp, they assume worst case and run fans. Reconnecting the sensor properly fixed the reading and the fans behaved normally again. This shows how a single sensor glitch can cause odd behavior, fans running, which one might think is a fan problem, but it was just following faulty data. Resolution. Replacing or fixing the sensor will clear its fault and restore normal operation of whatever system it fed. After repair, clear codes and test all related functionalities. For example, if it was a brake pedal sensor issue that affected regenerative braking, test that region is now working smoothly once the sensor is fixed. If it was a battery voltage sensing issue that caused charging to stop, ensure you can now charge to 100% without problem. In summary, communication faults in EVs can be as minor as a loose connector or as complex as debugging the CAN network. The approach is logical. Identify what's not talking, then find out why: broken wire, bad module, etc. And for sensor issues, treat them like you would in any car, but keep in mind EVs sometimes have multiple sensors for redundancy, so a comparison between them is possible. Communication and sensor reliability is crucial since EVs heavily rely on accurate data to operate safely.